सो आज हम लोग सीखेंगे ब्लॉकचेन में सॉलिडिटी in which we will learn about writing smart contract. Okay, तो चलो स्टार्ट करते हैं। एक बार आप लोग मुझे देख नहीं रहा होगा कुछ चलिए आई एम डूइंग इट। ओके, स्क्रीन स्क्रीन शेयर हो रही है तो वॉइस आ रही है नहीं आ रही, सिस्टम ऑडियो ओके।
Review, you can go back to my original Web3 roadmap and you can see it for the first 30 minutes. If not, hopefully this was clear. Now let's move on to how you can write smart contracts on Ethereum. Every blockchain has its own sort of stack to write a smart contract. Ethereum specifically introduced a new language called Solidity. So just like in when you're writing browser code, when you're writing front end code, you write your code in JavaScript, you write your code in React. On backend, you use Rust, you use Golang, you use Node.js. If you want to write a smart contract and deploy it on the Ethereum blockchain, you have to use this new language called Solidity. You have to understand this Solidity. Why a new language? That's what the Ethereum folks decided. Okay, we need a new language. And this is a very sort of contract centric language. So if you want to create this thing called a smart contract, it gives you the right constructs for it. Cool. For the next an hour and a half or so, we are going to do this. Alrighty. So for the next hour or so, we are going to first go through 4 modules, 1, 2, 3, 4. The first module, we're going to understand very basic syntax of Solidity. How can you write a contract? How can you write functions? How can you write variables? What are scopes, public, private? If you're from a Java background, you already know this, or even C++. Um, how to do hashing or random number generation in Solidity. One
So what some looked at as functions, variables, scopes, hashing, what's the parse function language, share function, basic arithmetic, address, request, inheritance, important, storage versus memory, function, invisibility, okay, importability, open zipline, nice. Function modifications, stack optimization, time and solidity, storage optimization. Okay, sending Ethereum safe random number generation. Okay, calendar grant, array calendar contract.
Once you've done that, what is a view, what is a pure function, and basic arithmetic, which is like plus, minus, modulus, things like these. Oh, did my pen just die?
Oh, should I let that now? So, in the live stream, वैसे भी कोई नहीं देख रहा, क्यों ना ऐड किया जाए, भी ऐड वाइड करते शेयर व्हाट्सएप पे ओपन और let's call Akash. देखते हैं, चाँद रहने का मतलब। हेलो हेलो, क्या कर रहा है? अच्छा ठीक है, मैंने देखो लिंक भेजी है, वो ज्वाइन कर। क्या है? कर तो सही। बोल ना, नहीं जा रहा हूँ। यही कर ले, एक बार देख लेता, एक बार 2 मिनट सारे। हाँ तो लाइव स्ट्रीम चल रही है, ज्वाइन हो सकता है, ज्वाइन कर ले। हाँ तो उधर होने के बाद हाँ ठीक है। हाँ चल जान दो, कोई फायदा नहीं।
That's fine. Yeah, it did die. That's all good. The second part, we're going to, let me zoom in here, understand this thing called cross contract calls, which means how one contract can directly call another contract. You don't necessarily have to call it from a browser. If you call a contract which will call another contract, think of it being very similar to a website like Udemy, where you pay, but the payment actually goes from Udemy server to Razorpay servers, and then the finally payment is confirmed, and then they get back a response and it comes back to you. Okay, one smart contract can call another smart contract. How? We will see here, and a bunch of other things. In the third part, we're going to understand how you can optimize your contract. This basically means how you'll understand where does gas go, what is gas, why is it always said that Ethereum is very expensive, and any interaction that you want to do there, you have to pay money, and how you can optimize your smart contract so your end user doesn't have to pay a lot of money. Finally, point 4 is payments, which is very important. The biggest use case of Ethereum is that you can transfer ETH when you're calling a smart contract. If you remember a few minutes ago, I said you can create a smart contract where I send some ETH, I get back some Doge. I send some Doge, I get back some ETH. So you can not just call functions, you can also send tokens or send Ethereum when you're calling a function. How you do it, we will understand in this module. These 4 modules are enough to understand the basics of Solidity. Once we've done that, we will move to creating our own calendar contract where, as I said, you can call a function and send some ETH with it. When you do, somehow a Google Meet link gets created as a calendar invite between you and me. Once that's done, we'll also write the front end for it in React. So you'll understand how once the thing is deployed on the Ethereum network, how you don't need a backend of your own. You don't need to have a Node.js backend. You can simply always just interact with the Ethereum blockchain to do things like creating a meeting between you and me, just calling the contract directly rather than a centralized server in the middle. So you don't need AWS, you don't need GCP. There is a network out there and you simply interact with the network, do function calls there. Cool.
Okay.
That is going to be the high level structure. Let's get into module 1, which is basics of the language. So at this point, I would urge you to go to cryptozombies.io. This is a website that makes it very easy for you to understand Solidity. I will be solving all the challenges here, and that will be a way for us to learn. I urge you to do it side by side or just close the video and do the challenges yourself. Either way, this is probably the best resource to understand the basics of Solidity. Extremely beginner friendly, and it sort of gamifies the whole experience. The only downside is it's a very weird sort of a use case that they make you build, that they make you write the contract for. So it might feel a little weird as to why we're writing this contract, but the goal is not to write a contract. The goal is to understand Solidity. Cool. You can go to cryptozombies.io, and I would urge you to sign up. You don't have to, but it like gives you a bunch of pop-ups throughout if you don't sign up. So I just sign up. I'm good. Alrighty. Once you do it, you will see a bunch of courses. The courses that we will be going through is 1, 2, 3, and 4. These are the 4 modules that I just discussed. And these should make you enough decently proficient in Solidity for you to be able to write your own contracts. Cool. Let's get into the first one. As I've said, this might feel a little weird, so just bear with me for a few minutes. And once you start writing code, this will become slightly easy. Cool. Chapter 1, the lesson overview. Oh shoot, am I sharing the right thing? I am not sharing the right thing. We will restart. So I just said 2 things. The first thing I said was go to cryptozombies.io and you can basically follow along the challenge, start coding with me. It's always good to code yourself and not look at someone else. If not, feel free to just look at me and passively watch me learn Solidity for the 4th time. I've done this a few times now. Cool. This has a bunch of challenges. Specifically, the one that we need to go through today is the Solidity challenge. So if you go to cryptozombies.io, go to the courses section. It's completely free. My internet is a little wonky today. If you click on the Solidity beginner to intermediate smart contracts, that should take you to the first thing that we're doing today, which is this guy right here. Click on start now. It has a bunch of modules. We have to do the first 4 modules, and those should be good enough for you to start writing the contract that we have discussed. Cool. Let's start with the first one. The first module, so this is the point where things might feel a little weird, but bear with me for some time. What we have to build here is a game. You might ask why on-chain games. I would say just bear with me. The goal is to understand Solidity. So this is a weird use case that we're building, but on-chain games are a thing. But yeah, you might feel why. I feel the same. Cool. What does it say? It says you're going to build a zombie factory, which is what our contract is going to be, to build an army of zombies. Compare it to a game where there is a game, Web2 game, where you go to zombies.com and you can create a zombie of your own there. You sign up, you get back a zombie. Cool. So you're creating a game rather than there being a centralized backend. It is running on the Ethereum blockchain. How? We will come to. Our factory will maintain, now what is factory here? It's just a game. Think of it like a game. Our game will maintain a database of all zombies in our army. So if on a Web2 website, 100 people log in some database, there are some 100 users and each of them have a zombie associated to them. Similarly, we have to do the same thing on chain. Our factory will have a function for creating a new zombie. In the Web2 world, this is simply you signing up and maybe clicking on a button that says create a new zombie. Cool. When we finally create the front end for it, if we create the front end for it, we won't in this video, but if you want to, after you've deployed this, you can create a website where there is a button, person clicks on the button and a new zombie is created for them. Each zombie will have a random and unique appearance. So this is slightly important. When you go to a website, let's say a Web2 game that lets you create zombies, you might get a unique zombie or you might expect a unique zombie from the backend, which is your character basically. Question is, how do you describe what the character looks like? A character could have some characteristics, which is like the head it has, the eyes it has, the shirt it has, the skin it has, eye color, and the clothes it has. There are a bunch of permutations and combinations of these which will create a unique zombie. Question is, how can you describe this in the simplest format so we can store it on chain? You could either have like 7 different variables which are like head gene number 1, eye gene number 2, shirt gene number 3, and you can store these as different variables in your database in a Web2 world, in the Web3 world, in your contract. Or you can have a single very long number such that the first 2 digits represent your head, the next 2 digits represent your eye, so on and so forth. Okay, you might ask, Sarkirat, there are only 7 head genes, which is why if you have a DNA, you can simply say the head is the first 2 digits modulo 7. So if 83 modulo 7 is 0, that means this specific zombie has this sort of a hat. If it is 1, then it means this. Or if you want to do it on a 1 based indexing, if 83 modulo 7 plus 1 is 1, then you have this hat. If it's 2, then you have this hat, so on and so forth. Similarly, the next 2 digits represent the eye that they have. The next 2 digits represent the shirt that they have, so on and so forth. So effectively in a single number, you can store the shape of your zombie somewhere. So if you had a Web2 website, you can simply ask the user to sign up using username and password, email and password, and you can randomly generate a very long, whatever this is, like 16-digit number. And based on the 16-digit number, the appearance can change on the front end of your game. The game will simply calculate what the zombie looks like based on this DNA. So this very long string, the DNA, is a nice way for you to represent the Web2 in a very simple format that can be stored on chain versus you storing, okay, the head is of type black hat and the eye is of type chashme or specs, so on and so forth. Cool. So what have we understood in this module? We've understood that these guys say, we have to create a contract that lets users create zombies, and each zombie is identified uniquely by a 16-digit number. So maybe we have to randomly generate this number. What happens if 2 people get the same zombie? We'll get to it. Don't worry about it just yet. Assume that won't happen. And like our random generation is random enough so that even if 10 million users hit your website, each one of them will have a unique zombie. Cool. Let's move on. Chapter 2. Contracts. So here is where we understand how you write contracts. Think of a contract or the code that you have to write here. So there is a coding section here where you can write the code. There is a check answer button here, and there is a question on the left. This is similar to lead code. There is a question on the left. You have to code something and click on check answer. If it is right, it will give you an AC, else it will give you a wrong answer. The first thing it asks us to do is create this thing called as a contract. And if you read through it, it says Solidity's code is encapsulated in contracts. A contract is a fundamental building block of Ethereum. You can think of it very similar to classes in Java or JavaScript or structs in Rust. They basically let you store a bunch of data and have a bunch of associated methods. That's effectively all a contract is. Now, there are some specific things that Ethereum has, which are like you can store Ether in the contract, and it has some more things and specific things to the blockchain.